Good day. My name's Ian Parney. I'm a neurosurgeon here at Mayo Clinic in Rochester, Minnesota, where I'm the vice chair for research for our department. And it's my pleasure to share with you a little bit about the research opportunities in our department for incoming residents. So just to kind of give you a very 40,000 view look into our academic activity, we're a very academic department. There's a total of 24 faculty, 20 clinical investigators, and 4 full-time research investigators. There have been over 350 unique publications in the department in 2019. It's actually a little bit difficult to track down exactly how many. I can come up with at least 400 through PubMed, but there's a certain amount of overlap between co-investigators within the department. We have a lot of funding from NIH, foundations, industry, and development. Like everybody, we've been dealing with COVID here, and just to give you a flavor of what that meant to us, when we had our true lockdown here in Minnesota in April of this year, we developed the Neurosurgery Social Isolation Challenge. And this was for all our faculty and trainees. Over the 30 days, we had a goal that we wanted to get 75 manuscripts or grants submitted in that 30-day period. That seemed like a goal that was ambitious, but we could maybe reach that. In fact, we were able to see 160 submissions in that time period, 134 manuscripts, 19 grants, and 7 chapters. So just hit it out of the park with that. And in follow-up to this, of those 160 submissions, 102 have been accepted, 49 are under review, and only 9 were rejected and not resubmitted. And this really seemed to have a bit of a hangover effect in a beneficial way to the department. The number of submissions of similar grants, manuscripts, et cetera, in the subsequent months, were 93, 70, and 90 for May, June, and July. So a substantial number and increase in submissions over this time frame. So what do we do for research activities here? How do we support this from the department? So we do a number of things. We have research rounds now are increasingly incorporated into our neurosurgical grand rounds, where we have faculty present at least once a month of research activities that they've been doing over the past year. We have at times a specific aims club, which is a place where if you have a grant, you can have that grant wood chopped a little bit and get feedback before you submit it to grant agency. We conduct an annual research symposium. This is typically an in-person event over 2 days with a visiting professor. Of course, this year it was virtual. We had 60 abstracts submitted by trainees in the department and presented those as a combination of talks virtually and electronic posters, as well as we were very fortunate to have Professor Alan Benabid from University of Grenoble, who's essentially the father of modern deep brain stimulation surgery, and a prior Lasker winner, come and speak to us as well. We have committees that I chair both in Rochester and across the Mayo Clinic enterprise to help coordinate research endeavors. And as I'll talk a little bit further about later, we have a clinical trials administration unit and technology development program within the department as well. So for residents, for trainees, how does this look? What sort of research opportunities would you have coming here? Well, they occur throughout the residency. We do have built into the program in the PGY 5 and 6 years elective time that residents will have the opportunity to perform basic or clinical research and or complete enfolded clinical fellowships or other clinical training in that time. It's elective time. But that's a time that you could potentially have full-time for research activities if you were interested in doing that. And so the opportunities for research are independently tailored to each individual resident, and they're flexible. It depends on what you want to do and how you want to do it. And we want to help you get there. So there are tremendous clinical research opportunities within the department. Every single faculty member has ongoing clinical research projects, and I've listed a number of highlights here. But the bottom line is that for any given area within surgery, we have 2 or 3 world-beating experts that would be delighted to work with you on clinical research projects related to their areas of expertise. Just to give you a flavor of what that really looks like, I want to kind of talk about the all-stars in our department. So put this in context. Most clinical neurosurgical departments, academic neurosurgical departments, if you had somebody who had 10 publications in a year, that person would be the unquestioned just superstar academically. You know, if you have 10 publications in our department, you're probably not in the top 75%. Here are some of the folks. Giuseppe Lanzino, 679 total publications as of today. In 2019, he had 85 publications in that year. Rob Spinner, our chair, peripheral nerve expert, you know, 569 publications, 52 in 2019. Mike Link, arguably one of the best known skull-based surgeons in the world, over 300 publications and growing, 33 in 2019. And Mo Biden. Mo is a spine surgeon, but his academic output is not just limited to spine. He really is a neuroinformatics expert, big data and databases, both within Mayo and nationally, that he runs. Over 300 publications already quite early in his career, 73 in 2019. So these folks are just incredible. And that's kind of the flavor of what you get looking at things here in Mayo and Rochester. We're not just limited to clinical research. We have 12 funded laboratories within the department. Just to kind of give you a flavor of what's involved with that and who does what, you know, Dr. Spinner and Dr. Wang run the spinal cord and peripheral nerve regenerative laboratory, which studies exactly what that says. Dr. Kendall Lee has established here the neural engineering laboratory, and he's devoted to understanding the mechanisms of action and developing the next generation of deep brain stimulators for lots of different areas within neurosurgery and functional neurosurgery. As I'll highlight for you here in a little bit, Dr. Lee's efforts really were a catalyst that attracted a number of other people here as well that are now running their own independent laboratories within the department. My lab, the neurosurgical oncology lab, is focused on glioma-mediated immunosuppression and immunotherapy. I run a number of clinical trials, both at Mayo and across the country, of novel vaccines and immune checkpoint inhibitors. And then the lab itself is very focused on immunosuppression mediated by gliomas, often through immunosuppressive monocytes and extracellular vesicles. Dave Daniels is one of our pediatric neurosurgeons. Dave trained with us here. He actually did a postdoc in my lab, and he's now established an increasingly successful and well-funded pediatric brain tumor lab. He is obviously focused on developing cell lines and animal models for pediatric brain tumors. Dave has a PhD in medicinal chemistry, and so is highly focused on developing new treatment strategies for malignant brain tumors in pediatrics. My partner clinically is Dr. Terry Burns. Terry and I are both clinician scientists. We share a lab space along with Dr. Daniels, and he and I actually alternate clinical week and a research week. Terry's research efforts are really focused on reversing iatrogenic brain injury following radiation in brain tumors, and novel therapeutic monitoring cerebral microdialysis for brain tumor therapy. He has a big interest in senolytics, the idea how aging and tumor biology is similar and could be impacted in similar ways. Kai Miller is one of our newer faculty. That's not a typo. He actually has 2 PhDs. And he's established what I'm calling a brain connectivity laboratory. Some of these names for the labs, I'll admit, are mostly names that I've made up to describe what folks are doing, but I think it allows you to focus a little bit more on what's going on. So Kai is really at the leading edge of brain-machine interface work and understanding complex brain neural pathways. He has projects that are ongoing for figuring out how to develop brain-mediated movement for people that have paralysis or other neurodegenerative disorders that prevent movement. So really pretty spectacular stuff. Luis Savastano is one of our newest faculty. He has a tremendous background in developing novel endovascular techniques, actual angioscopy, looking into blood vessels with an angioscope, not science fiction, but actually happening. Novel ways to do clot disruption as opposed to clot retrieval, so that you avoid sort of the embolic phenomenon that can happen when you just tear out a clot by trying to pull it out. He can actually morselize it. A lot of this revolves around really innovative things that he's done to develop new technology, new techniques to achieve these clinical goals. Dr. Miyun Zhang is a full-time PhD scientist in the department. She focuses on regenerative neurobiology and stem cells, adult neurogenesis, and increasingly the BUB-R1 pathway in oligodendrocyte proliferation myelination, and its role in recovery after injury from chemotherapy. She's a big expert in chemo brain. Louis Lujan is also in the department as a PhD scientist. He runs what I would term a neural stimulation laboratory. And really, this is focusing on the in vivo and in situ interrogation of neural function after stimulation. What happens when you put things into the brain or even the spinal cord and stimulate? Can we learn more about how to optimize that from those studies? Dr. Xiuyang Chang also runs a DBS laboratory here, and she's really focused on modeling DBS in animal models, both small animal models, and as you can see here, large animal models in a swine model, to understand the mechanisms of DBS. It's amazing that this thing that we do in neurosurgery works so well, and we have a reasonable idea of some of the basics of how it works, but there's actually a fair number of unknowns in there. And so Dr. Chang is really tracking those down. There's a couple of people in the department that run funded research efforts in collaboration with other established laboratories. So Dr. Ben Elder, who is one of our complex spine surgeons, works within Mikey Zemsky's biomechanical lab and is focused on improving spinal fusion. And Dr. Jamie Van Gumpel, who is our program director, one of our skull-based surgeons, and has a clinical interest in epilepsy surgeon, has well-established collaborations with Dr. Greg Worrell's epilepsy lab, focusing on treating epilepsy with novel restorative rather than ablative techniques. So that kind of gives you a view into what's going on in the labs in neurosurgery here. But as residents coming into the neurosurgery program here, just remember that there's actually unlimited additional research possibilities. And just a short list here at Mayo Clinic would be neuro-oncology, epilepsy, pathology, radiation oncology, neurovascular things. There's also opportunities for you to work with folks elsewhere if there are compelling things that you want to study that we don't necessarily have here. And frankly, there's not too many of those things. But if there were, and you wanted to go somewhere else to study and get a compelling reason for that, we're open to that to allow you to have that flexibility. Just some other additional resources that are available within the department to support research. We have what could be described as a clinical research administrative group. This is really our group for running clinical trials. Bambi Wessel is the administrator that runs that. And Bambi is a force of nature. You'll love working with her. She supervises 8 clinical research coordinators. It's a growing number, partly funded by the department, but largely funded by grants coming in from people running clinical trials. We currently have over 35 ongoing clinical trials with neurosurgeons as PIs being run through Mayo Clinic in Rochester. And I'm not talking just about, industry-sponsored trials or your local PI. I'm talking about, local and national studies with neurosurgeons as PIs. I don't think there's too many places that would have that clinical trial infrastructure. We have a program in combination or in collaboration with Mayo Clinic Ventures on technology development. And this is the commercialization. How do we get these great ideas protected for their intellectual property? How do we get those to industry and spin things off that way? So Stefan Mandensing is our newly hired technology development associate. We've had this position for a while. There was somebody in transition. Stefan is starting in January. We're also moving forward with getting science writer and science artist, with specific connections to our department, so you'd have access to those folks. So in practical terms, how does this work? Well, I want to meet with every resident every year to talk about your research interests. Even if your research interests are, I'm not interested in research, I want to know about that. And then maybe we can figure out how to convince you that you might want to do some more research. So we'll discuss your goals, whether those are clinical, translational, basic science, or nothing. Want to identify appropriate mentors and resources for you. Because when you come in, you don't necessarily have the perfect idea of what you want to do because you haven't experienced everything yet. And you don't really know who's available to do what with you here at Mayo Clinic. And so we want to get you connected so that you have some ideas of where you can go and how you can work on projects. Also want to get people thinking about appropriate training programs for advanced diplomas and degrees. And I'll talk a little bit more about this as we go forward, because these are available here and they're really good. And you should take advantage of them when you have the opportunity, but you have to think about it a little bit in advance. And then we want to review how things are going from year to year. Your goals from last year, are they still the same this year? How can we help you? What can we do to really help optimize all of that? So yeah, you might be able to pursue some advanced qualifications in research while you're here training as a resident. So there's a few things we'll talk about: the CITP, CCATs, and then the master's and PhD programs. So a bunch of acronyms I'm throwing at you. Let's try and break that down a little bit. So the CITP is the Clinician Investigator Training Program. So this is a Mayo-based program that provides formal research training for academically oriented residents. It's for those pursuing a career that includes research within a robust clinical practice. And the goal is to have produced physician scientists who lead successful extramurally funded research programs. It requires 2 years of dedicated mentored research, so it doesn't extend your residency beyond the 7 years. It's available to all training programs. So it's not like it's just neurosurgery. This is, you could be a resident in anything at Mayo Clinic and you'd be eligible for this program. And they only actually take up to 11. I think it might be a little bit higher than that now, but not much higher than 11 people per year. So it can be a little bit competitive to get in. Though I'll say we've never had a neurosurgery resident who applied for it who didn't get it. It's mentor-based. This is kind of an old slide that says more than 60 mentors to date. I imagine it's probably more than 150 mentors at the moment. And the research could be basic, translational, or clinical. Though I would say I think that the CITP program has a little bit of a slant towards basic and translational research. You got to apply at least a year in advance. It's no use coming to me at the beginning of or the end of your PGY 4 years to going into your elected PGY 5 and 6 years and saying that you'd like to do the CITP program. We've got to have thought about this in advance. So that's why I want to meet with everybody on a regular basis to make sure that we plan these things out well in advance. So there's some didactic components to this. There's clinician investigator seminars and research seminars within the department. There's also a curriculum specifically to the CITP program for grant writing, manuscript writing, clinical trial statistics, and ethics. And you also have the opportunity to audit Mayo Clinic graduate school courses if you're interested in doing that. From a neurosurgery perspective, the advantages of this is that it allows you to have a really lengthy relationship with a particular mentor and adds structure beyond the mentor's experience to your research training. So for example, I'm a pretty good guy. I'm a pretty good brain tumor surgeon, clinician, investigator, translational scientist and things, but there's no doubt that, my knowledge, like anybody's knowledge, is going to be limited. You go to a program like this, you get all the benefits of working with me, but you'll also get all the benefits of all this other structured activity that really enhances your training experience. It doesn't lengthen the training program, and it increases your competitiveness for federal funding when you graduate. So to that point, the CITP outcomes of people who've gone through it, about 75% of the people who've gone through are on faculty at academic centers. 50% of them actually are on faculty at Mayo Clinic. 50% have more than 50% of their time funded by external research funding, and 75% have more than 20% of their time funded by external research funding. So pretty successful. All right, so that's the CITP program. Let's talk about CCATs, the Center for Clinical and Translational Science. So this is a big U grant that Mayo gets. It's millions, almost tens of millions of dollars over a number of years to fund this. There's an educational component to that, and that requires a commitment of time. You can do a master's degree through CCATs. The commitment for that is 2 years. There's some curriculum requirements. You have to have a thesis with 2 to 3 publications, individualized coursework, and a mentored research experience. And the outcome from this is that you get a master's degree from the Mayo Graduate School. There is also a postdoctoral diploma program where the commitment is only 1 year. Also has some curriculum requirements in terms of having a manuscript, individualized coursework, and a mentored research experience, and you get a diploma from CCATs. So the big advantage of this is that it's 1 year, not 2 years. The big disadvantage is that you get a diploma from CCATs, which means something in Rochester, Minnesota, but it's not going to mean as much elsewhere as like a master's degree might. The 1 year and 2 years, you didn't hear it from me, but there might be a little bit of flexibility built into that. So one of our recent graduates, Dr. Chris Graffio, managed to combine an infolded skull base fellowship with the 2-year master's program, and made a pretty compelling argument to the CCATs folks that the skull base fellowship was really part of his research training. So there may be some flexibility within that. Let's talk a little bit about basic science graduate degrees during residency. So since I've come along as the vice chair for the department, we've established an enfolded PhD program. This is a residency PhD, kind of analogous to doing an MD PhD in medical school. And we actually have the graduate school agree that these types of things are analogous, so that our resident PhD students get a little bit of credit for time served, just like the MD PhD students. They don't have to go back to square one for all the courses that you might have to take otherwise. You can test out of some of them and not have to do it. So some of that happens online. You got to, or the outline for that is you got to identify early, because we got to be thinking about this. We'd actually have students enroll in their PGY 4-year, or residents enroll in their PGY 4-year while you're still on the clinical service. Now, the PGY 4-year isn't maybe as busy as some of the PGY 1 to 3 years clinically. It's not time off by any means, but it's a little bit more flexible. And so the idea here is that you might be able to work through some things online to test out of some of the courses. Full-time in a lab in the PGY 5 to 7 years. And then complete your clinical training in your PGY 8-year and defend your thesis at that time. So the goal is that you enroll PGY 4, full-time in the lab, PGY 5 through 7, be ready to defend your thesis at the end of that time, but you might not defend it until you're back as a chief resident. This is available in multiple streams in neuroscience, immunology, bioengineering, regenerative medicine, biochemistry, molecular biology, number of different areas. One caveat I would say is that while bioengineering sounds and is a good fit for a lot of things in neurosurgery, it turns out that a lot of neurosurgery residents coming in haven't taken a lot of engineering courses, so you might not have the same flexibility in avoiding some of the coursework that you would have in the other streams, and it might be a little bit more challenging to fit that in within the context of the residency. So this does increase the length of training by 1 year, but only by 1 year. And then you would be able to say that you have gotten a PhD, which obviously sets you up for success as a clinician scientist later. There are opportunities for master's degrees in molecular neuroscience. They're a little bit more limited. 1 year of lab research is a minimum, with some coursework and obviously a thesis and mentored-based program. I want to talk a little bit about some of the other resources within the institution, and just highlight in particular the Center for Regenerative Medicine. This is the Mayo Clinic Center for Regenerative Medicine and Neurosciences, which covers a lot of things, as you can see here. CRM, as it's known here, casts a pretty wide net as to what they view as regenerative medicine. And so there's some opportunity for resources here that you can access and for working. And as I said, they've actually established their own PhD program, which may be an attractive PhD track for some of our residents coming through who are interested in that. There's a number of other centers, the Center for Science and Healthcare Delivery for Individualized Medicine, which houses basically all of our omics groups, the Cancer Center, Center for Biomedical Discovery, Innovation, Mayo Clinic Ventures, I mentioned before, is our intellectual property and industry relations group. And they work very closely with the Department of Business Development and the Minnesota Biobusiness Center. So with that, I'll stop. And we can't have any in-person questions or discussion at this time. But if you have questions for me, I'm always available through email. It's parney.ian@mayo.edu. And I'd be happy to go over anything that you'd want to know about research at Mayo Clinic or anything else within the Department of Neurosurgery. Thanks very much for your attention.